Hello students, in this video I am going to discuss about the second part of electromagnetic induction chapter. Basically in the first part I covered basics of electromagnetic induction and the force experienced by a conductor in a magnetic field. So in this particular video I will be discussing how to use the left hand rule and right hand rule to find the direction of the induced EMF for current or magnetic field. First, let us start with a very simple rule which is called thumb rule. So in that case, suppose this is a wire which is carrying current and the current is in say upward direction, and my thumb indicates the direction of the current and the fingers which are curling gives the direction of the magnetic field. At the same time, if I reverse the direction of the current, then you can see thumbs are actually clockwise in this case. So this means the magnetic field is clockwise, and when we put the thumb in the upward direction, so current is in the upward direction, in that case the magnetic field is basically, you can see closing fingers are in the anti-clockwise direction. So this is basically the rule for finding the direction of the current and magnetic field. Now let us discuss about the right hand rule, which is Fleming's right hand rule. Now many students get confused over using Fleming's right hand rule and Fleming's left hand rule. Where to use right hand rule and where to use left hand rule? Very simple is, right hand rule is basically used when there is motional EMF, means whenever you see there is a principle of electromagnetic induction, so we use right hand rule, Fleming's right hand rule. And according to Fleming's right hand rule, so this is Fleming's right hand rule, my index finger gives the direction of the magnetic field, middle finger gives the direction of the current, and thumb gives the direction of the force or motion. Okay, so this is Fleming's right hand rule. This rule is particularly useful in case of generator. So generator is a device we know which is based on the phenomena of electromagnetic induction. And of course we know that in case of generator, it actually converts mechanical energy into electrical energy. Now when we talk about motor, we use left hand rule. Now basically what is the principle behind the motor? Motor is based on the principle of a conductor placed in a magnetic field. It will experience some force. Means when a current carrying conductor is placed in magnetic field, it will experience a force. So on that principle motor is based. So in that case we will be using left hand rule. So according to Fleming's left hand rule, this is Fleming's left hand rule. Remember, whether it is right hand rule or left hand rule, all the fingers are mutually perpendicular to each other. So here in case of left hand rule, this will show the force, this is the, of course, magnetic field, this is current. So this will give you left hand rule. So whenever you want, you are using to find out direction of the current or magnetic field, etc., you can use left hand rule. And of course, when you see electromagnetic induction, this process is involved, on that time you are going to use right hand rule. So these are the three rules: thumb rule, Fleming's left hand rule and Fleming's right hand rule. These rules helps us to find out the direction of the induced EMF, direction of current, magnetic field, and as I said, remember all these this rule, LH rule and RH rule, they in this case the magnetic field, current and the force or motion, they all are mutually perpendicular to each other. Now suppose we have a wire like this, and in this direction current is flowing. So if you want to find out in which direction magnetic field is, so of course, so this is the condition. So here you can see my fingers curling inward. Inward means this is the plane of the paper. This board is the plane of the paper. So it is coming outward. So outward towards me. So this is the direction of the magnetic field. This means magnetic field is outward here. And similarly, if I change the direction of the current, so direction of current is in this direction, that is from right to left. So in this case, again you can see the fingers are curling inward. So this is the direction of the magnetic field. It is into this paper or into this board. So that is how we can find out the direction of the magnetic field using thumb rule. Okay, sorry, yeah, thumb rule. And in this case, left hand rule and right hand rule I have already discussed. Right hand rule will be used to find out the direction of the current or magnetic field, etc. in electromagnetic induction, wherever this principle is involved. And where you find that a current carrying conductor is placed in a magnetic field, there we use left hand rule to find out force or direction of current or magnetic field. Thank you for this particular video.